Good morning, folks. This is Mr. Walker here, coming to you with our next lesson about logs. Now, folks, in order for us to get used to this, we got to first look at our calculator. Uh, Please note, this is going to be one of those things where you have to use our calculator, okay? The TI-83. If you don't have this, you are not going to do well. Okay, you might be able to pull this off with a scientific calculator or anything above an 83, but most phone calculators do not have the functions we are going to mess with today. So first off, let's identify the button that we want to focus on. If you look at the button left to the 7, you'll see our log button. Now, things to note, when we deal with the log, our logs are going to be in base 10. That's why you don't see a small number next to this, okay? Now, along with this being base 10, whatever we put inside of our number, that is our answer to whatever the exponential is that we're looking at. So for this right here is technically, let's go through, let's just rewrite it. If I have log of 5, like how this is written, this is really saying log base 10 of 5. And now we're asking, what does it equal? Now, if you were going to go through and deal with it like this is really in exponential form. 10 to our question mark power equals 5. Now, when you hit enter here, this will give us what that actual question mark is, the actual power. Now, I don't believe you can turn these into fractions. Nope. So these are decimals that are going to be never ending, non repeating. Usually, when we deal with this, we're going to probably round to the thousands or the hundreds place, just not going to get the whole 9 digits that they see here. 'Cause this is only the 9 digits that we're seeing. Okay. This might have more digits, this might have less digits. But all that aside, let's talk about how can we put our other types of logs in the calculator. Because like I said, this log is only dealing with base 10. So we got to go through and deal with that. All right, let's talk about our notes so we can go into this a little more. All right, first question we got here is what type of logarithm does your calculator know how to calculate? So this calculator, like we said, calculates logs as if whatever its base was 10. Now everything else we're not really worried about it, but this is a log of base 10. So whatever we're dealing with on the large number side or the equal side has something to do with 10 as our original base. Now, how do we change the base of any of our logs so we can go through and solve this? Let's go through and address our original form for this. Okay. So originally, when we deal with our logs, they are exponential equations. Let me skinny this up a bit. So we have some base b to the x power equals some number a. Okay. And this can go any type of numbers. We're just going to go with these basic ones right now. All right. First step in this is we are going to take the log of base 10 of both sides. Now, this is going to sound weird the first time you see it, but once we start really getting into doing it, it'll seem a little easier. Okay. So, what do I mean by take the log of base 10 of both sides? I legitimately mean that both sides here, b to the x, and on the other side, a, we are going to take the log function to base 10 of legitimately both sides. All right. First step done. Second step that we got to go through to do is solve for x. Okay, so step 2, solve for x. All right, how do we solve for x here? First off, we got to go through some of the different properties with logs. All right, first off, look at your log. Note over here, we see that there's a b with an exponent. So whenever we see our number in front of the log with an exponent, we have to do the power rule. Now, the power rule takes this exponent here, this x, and it pulls it in front of the log as a coefficient. So let's go through and do some math, people. So moving this is going to make our problem change from what it is originally to x being in the front, and then we have the rest of the stuff. So we have log of base 10 of b equals log of base 10 of a. Now, this is an equation. We're solving for x. So we deal with the x the same way we've done things in the past, okay? So right now, x and log base 10 of b are being multiplied to each other. In order to get x by itself, we are going to have to divide both sides here by log base 10 of b. So we got that here, log base 10 of b. Okay, obviously on this side, based off of what we've done a bajillion times at this point, these two cancel out, leaving us with x. Now this x here is our exponent, okay? Our exponent equals the log of base 10 of our answer divided by the log of base 10 of our original base. So whatever we go through and do here, this is going to actually go through and give us our final answer. Now, the way that this will look like in the calculator, obviously you won't see the tens there. This is really going to just be log of A over log B. Okay? So we're going to have to make sure that we know where all these parts come from. These B, the A, the X, this is all coming from the original version of our log, the original version of our exponential equation. So if you do give a log to you, you can go through, change it up, solve it up like how we did here, and then you'll be able to go through and find your missing exponent. So we're going to go through and deal with a couple of these. All right, we're going to do the top four. I'm going to leave the bottom six for you to practice with. Actually, I'll do the top four and the bottom left one here because I don't want to leave you too much of a lurch without a frame of reference. All right, let's talk about the top ones. All right, first off, we're going to do these one at a time, but things to note, I'm going to highlight a couple things before we jump into it, okay? First off, anything that I highlight here in yellow, that is our base, okay? Then everything that I highlight in red here, red, we're gonna make that our answer. That way we know what's popping off. Okay. So first things first. Let's go through and address some of our stuff in the log and also what are directions. We got all these logs here. Note there's no equal signs. So that means that all of these things that we're evaluating are for the exponent. That brings us from point B being our base to point A being our answer. All right. Next thing, you remember earlier when we looked at a log in the calculator, we got a lot of decimals here. So they want us to round to the nearest hundredth. Okay. So that is our second decimal place. We're going to make sure that we round. All right. First step, we're going to go through and acknowledge what's what. So first off, 30, that's our answer. 7, that's our base. So let's rewrite this equation and then start solving things. Okay. So we got 7 to some power equals 30.6. All right. So the way that the formula worked on the front, to find our exponent here, we take the log of both sides of this, and we're going to divide them. So on top of our division, we have the log of our answer, which is 30.6, divided by the log of our base, which is 7. Now, this isn't a normal division here, so you will need the calculator. Don't try to do this in your head because it's irrelevant. Head's not going to work for this. So let's turn on the calculator. Let's get you guys a better view of this. All right, so we got a log of 30.6, and we're dividing that by the log of 7. Now we don't have to worry about messing with the base or anything like that. This is going to go through and evaluate this to base 10. We're just going to hit enter after we get these parentheses closed. So from this, we get this decimal. This decimal represents the exponent that we need. So that means that if we take 7 to this decimal will round to the hundredths place. This is 1.76. This will get us our answer. So let's test that out. Okay. If you take 7, raise that up to the 1.76 power, we get 30.7. This is close enough for us to deal with this because, again, we did round to get this original decimal. If you kept this decimal that we got from the calculations, you will get exactly 30.6. Like, let me go through and do that just for argument's sake. So you believe that. Not that you wouldn't believe me, but you know. All right, we got this right here. Let's take 7 raised to, since this is a long decimal here, I'm just going to write the answer. Okay. To get that, you just hit second and the minus sign. So 7 to the answer is, in fact, 30.6. So that would give us our exact decimal. So you always go through to check this, make sure that your decimal gets you at least within a decimal place of your answer, or at least, you'd be able to round up to it, round down to it. Got to get in the ballpark because we are evaluating and rounding. Okay. All right. Let's take a look at the next one. First up, let's go through address our base. It's 2, and our answer, which is 13. So to solve for this, we take the log again of our answer and divide it by the log of our base. All right, let's work it up. So we got a log of 13 divided by a log of 2. This decimal right here is our power that takes 2 to 13. Let's check that it works. So we got 2 to the answer gives us 13. So, oops, sorry, it evaluated it twice. But 13 is, in fact, our final answer that 3.7 yada 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 will give you. Right? For this, we're rounding this to the hundredths place, so 3.7 will work. So the answer is 3.7. And down here, we'll just write this for keeping track that this does, in fact, work. Okay? All right. We're going to do 2 more. I'm going to do this one, and then I'll hop down and do this bottom left one just to walk you through it. Okay? All right. We got 5 and 4. We got our base and our answer. So let's go and highlight that. 5 is the base, 0.4 is the answer. So we just got to go through and let's log it up. So we got the log of our answer, 0.4, divided by the log of our base, which is 5. All right, let's hit this math up. Log, we got 0.4. Make sure you close off your parentheses. And then that's divided by log of 5. Close that up again. And this right here gave us a negative decimal. So let's check to see if this negative decimal is in fact right. So we put our base here, raised to our answer. Let's check. Point 0.4, 0.4. It is what it is. We got this. So this means that our answer here is, we're going to round this to the hundreds place. So 0.57. And that'll work for us. Okay. Now, again, remember, when we do check the rounded decimal, it's not going to give us the exact answer that we had before because we did round it. Okay. If you want to really check that your math is right, check the decimal that you got from the calculator first and then round for your answer. All right. One last one before we go. We got some math and some operations happening here. All right. So, first off, we got to go through and we got to find what this log here is going to represent. So we got 3 minus log base 1/2 of 20. So first off, we got to figure out what all this jazz is. And we're going to substitute it inside of this problem. So let's just write what our problem is. And this right here will be what we get from this. All right. So to the side, let's work out this math. We got the log of our answer, 20, divided by the log of our base, 1/2. Now, hitting that up in the calculator, let's get this up. There you go. We got log of 20 divided by log of 1/2. You can write this as point 0.5 or 1 divided by 2. Either one should work. So this gives us a negative decimal. This is negative 4.32. Yeah, this should be fine. So we're just going to say negative 4.32. Now, this right here is what all this jazz is inside of this circle. So when we substitute it back in, we take that negative 4.32, substitute that in there, and then we do some math. So we got 3 minus a negative. That really turns it into 3 plus what was in there. So 3 plus 4.32, which gives us 7.32. So, folks, if you ever have to go through and evaluate a log that is not of base 10, take the log of both sides of your exponential form of it, divide the log of the answer by the log of your base, and that'll give you what your exponent is. So, that is one way for you to go through and evaluate this in the calculator. Okay? All right, folks. The other ones, I'm going to leave that for you. And you also got some practice questions coming at you. So good luck, folks. Appreciate you watching.